Hello, these are our 12.3 notes and we'll be talking about measures of center and position. So before we do any calculations, we're going to go ahead and define some of these measures of center. So we have mean, the sum of the data divided by the number of pieces of data. This is what we normally call, or when we talk about average, this mean is that that same thing. Next, we have median. This is the value in the middle of a set of ranked data. So the value in the middle. Mode is the piece of data that occurs most frequently. And mid-range, the value halfway between the lowest and the highest values in a set of data. So we would calculate this by L plus H divided by 2. So the lowest value plus the highest value divided by 2. For the mean, this symbol here means the, oops, sorry. Okay, let me try this again since I couldn't do it. Okay. This is the sum of the data. So it is all the data added. Now, for the average or the mean, we use this. And we do the sum. So we add all that data, and then we divide with the number of pieces of data in. Okay, so let's look at how we do that over here in example 1. So we're supposed to find the mean, median, mode, and mid-range in each data set. So number 1, or A, we have 91, 95, 95, 97. Hold on. 91, 95, 99, 97, and 95. So for our mean, what we're going to do is we're going to add 91 plus 95 plus 99 plus 97 plus 95. And then we're going to divide by how many we have. 1, 2, 3, 4, 5. Divided by 5, we get 95.4. So the mean for this is 95.4. Now, for the median, we are supposed to figure out the value in the middle of a set of ranked data. So that means that we have to put these in an numerical order, in an increasing order. So we're going to write 91, 95, 95, 97, and 99. So we're reordering so that they are from the smallest to the largest. And the one that is in the middle, we have 5 pieces of data. So the one that is in the middle is the median. So that would be 95 here. Mode is the piece of data that occurs most frequently. Well, if we look at all these numbers that we do have 95 and 95. 2 of those, and all the other ones are just one set. So this would be 2. Mid-range is the value halfway between the lowest and the highest. So we're going to add the lowest and the highest, which in this case are 91 plus 99 divided by 2. So 91 plus 99, don't forget to press the enter, divided by 2. This would be 95. Okay, so let's move on to B. We have 94, 100, 95, 80, and 81. So 94 plus 100 plus 95 plus 80 plus 81. that would be 450. Well, we have 1, 2, 3, 4, 5 of them. So we're going to divide by 5 and we get 90. Okay, again, for the median, we need to reorder these. So 80, 81, 94, 95, and 100. So the median here is 94. Mode is the piece of data that occurs most frequently. Well, if we look at these numbers, we only have one of each, so there is no mode in this one. And then our mid-range, 80 plus 100 divided by 2. So 80 plus 100, enter, divided by 2 is 90. Let's move on to C. So now when we're calculating the average, we have 11 plus 6 plus 4. We don't have to type in the 0, but when we're counting how many pieces of data we have, you do have to count the zeros. 0 doesn't change anything on here. So it really doesn't. You can add it if you want to. I'm going to skip it on this addition. So divide it by. But now when I go and count how many we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, I am including the zeros because they are as part of the data. So the mean here is 4. And again, we need to reorder this 0, 0, 0, right? 3 zeros. 1, 2, 4, 6, 1, 2, 4, 6, 11, and 12. So the median, here are, I'm going to go ahead and start kind of covering these from the ends. So I see which one is the median. Well, the median happens to be 2. So I have 1, 2, 3, and 4 on both sides of that 2. So it is 2. Mode, well, over here, 0 is the one which is 3 times. All the others are ones. So 0 is the mode. And then the mid-range, 0 plus 12 divided by 2, which is 6. D, so 100 plus 100 plus 90 plus 30 plus 70 plus 100 divided by 1, 2, 3, 4, 5, 6. So we have a non-ending decimal number here. We could take like 2 decimals here and round it. Of course, there's a 6 next to it, so this would go up to 81.67. I'm going to go ahead and round it to the nearest 1, so that would be 82. If it doesn't tell you, I mean, MyMathLab will tell you what you need to round it to. So if it's if it's 2 decimal places, 1 decimal place, or whatever, it will give you the answer. And on the test, again, if you show your work, I can see what you've done and what, rounding you've used. For the median, we need to rearrange 30, 70, 90, 100, 100, and 100. So the median here, we're going to go 1, 2, 1, 2. Well, here we go. So we have 6 numbers. So we're going to, this would be the one that's kind of in the middle of the data set. So 90 plus 100 divided by 2 is 95. So our median here is 95. It is in between these two numbers, and 95 is there. If you're not sure how to get 95, you can always do the calculation. So add the numbers and divide it by 2. Mode is the one that occurs most frequently. Well, there's 1, 1, 1, 1, 2, 3. So it has to be 100. Mid-range is 30 plus 100 divided by 2. So 130 divided by 2 is 65. Next, we're going to go ahead and add again 75 plus 54 plus 82 plus 93 plus 82 plus 75. 461. And we've got 1, 2, 3, 4, 5, 6 numbers. Yes. Up my pen, I guess. So we're going to divide this by 6, and we get 76.83. Let me see if I can get any of this off. Of course not. It's just going to smear it more. So 76.83, I'm going to round it to 77 this time. Median. So again, we need to rearrange this. 54, 75, 75, 82, 82, and 93. Did I get it? 54, 75, 82, and 93. Yes, I got all of them. So again, for the median, 1, 2, 3. So we have an even number of the data. So we're going to look at 75 plus 80, 75 and 82. What is in between them? So 75 plus 82 divided by 2. 75 plus 82. Oops, 82. Enter. Divided by 2 is 78.5. Mode. So what do we have here? We have 2 75s and we have 2 82s. So both of those are our mode. And because we have 2, this is called bimodal. Bi means 2. So it's called a bimodal. Mid-range is going to be 93 plus 54 divided by 2, which comes to 73.5. Okay, next one. We have a -5, a -3, a 3, and a 5. So the mean, -5 plus -3 plus 3 plus 5 divided by 4. See what happened. It is 0. Because we have the negative and a positive number of each. They cancel each other out. Our median here is going to be between -3 and 3. Well, the number that's going to be right in between is a 0. Because 3 and -3 are the same distance away from 0 on the number line. So, well, mode, we only have one of each. So this is going to be no mode. And mid-range is going to be -5 plus 5 divided by 2. And again, -5 plus 5 is 0. Divided by 2, this is a 0. G. Let's see. We have 5 plus 5 plus 5 plus 5 plus 6 plus 7. 33, 1, 2, 3, 4, 5, 6, divided by 6, and we get 5.5. Where's my mean? 5.5. For the median, again, we're going to start here, kind of figuring out what number is in the middle. 1, 2, 1, 2, and we've got, since we have 6 numbers, we have the 5s in the middle, so our median is a 5. Our mode, we have 4 5s, so 5 is our mode. And then mid-range, 5 plus 7 divided by 2 is 6. Okay, let's move on to here. So graph each of the data sets on a number line, label each of the 4 measures of center on the number line. So this one here was actually our, from example 1, this is 1C. So we've already calculated the 4 measures of center. It's this one here. So what we need to do is we need to draw a number line here. I'm going to start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And now start graphing each of these. So we have 1, 11, we have 1, 6, we have a 4, we have a 0. We have a 2, 1, 12, and 0, and 0. And now we're going to go ahead and put the mean, median, and mode here as well. So the median, or the mean first. So our mean is here. Mean is 4. Our median is 2. Mode is 0. And our mid-range is 6. This one here is our 1D. So it's this one. So again, we're going to go ahead and draw a number line. This number line is going to be a little bit different because we're actually going to go ahead and go by tens instead of ones. Otherwise, going from 30 to 100 would require a lot more room. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, then I'm going to start plotting the numbers. 100, 100, 90, 30, 70, and 100. And so the mean is 82. So our mean is going to be somewhere around here. We can't really make it that accurate because we don't have the numbers between 80 and 90. Median is going to be 95. So that's kind of halfway here. Mode is 100. And then mid-range is 65. So that's again halfway between here. Next is going to be the one. Let me see. Is it easier to do it this way? Probably. Is going to be 1E. So this one here. And that's the pen that was Leaking. So we have numbers from 54 to 93. So what I'm going to do actually is I'm going to start with 50 and go in fives. 70, 75, 80, 85, 90, 95, and 100. So we've got 75, which is here. 54 is going to be somewhere here. 82 is going to be about halfway. 93 is a little bit over halfway. 82 again, and then 75 again. Our mean is 77. So 77 is somewhere here. Median 78.5. Well, I'm going to round that to 79. And that's going to be somewhere here. Mode. Remember, this is bimodal. So the mode is going to be both of these. And then mid-range is 73.5, which is about 74 mid-range. So there we have them on a number line. And you can see how different, I mean, we've got different numbers, but how the mid-range, mean, and median and mode are in different places for these. Okay, next we're going to go on to example 3, weighted average. Now, this is something that you can actually use when you're calculating or trying to figure out what your grade will be. Of course, we have more than just the midterm exam and a final exam. We have, the quizzes, and we have quizzes, tests, assessments, and final exam. Assignments, not assessments, assignments. So let's look at this. The midterm exam is worth 40% of your grade, and the final exam is worth 60%. If your midterm exam is 84 and your final exam grade is 94, calculate your final weighted average. So 40% means that we divide by 100 to make it into a decimal. So 0.4, and midterm exam grade is 84. So 0.4 times 84 plus 0.6 times 94. So 0.4 times 84 plus 0.6 times 94. And I made a mistake there. 0.4 times 84 plus 6 times, not 6, 0.6. 0.6 times 94. 90. So your grade would be 90 in this case. Now, for this class, this is all on your syllabus. Your assignments are 15%. Your quizzes are 5%. Your tests are 60%. And final exam, you can see if we add these, we get 80%. So whatever is left, 20%. So now you can actually go and calculate, what you need on your final exam if you want a certain grade. So for example, if you're, so you would just fill in whatever you have. So 0.15 times, for example, if your assignment grade is 85, let's put 85. Your quizzes are a little bit lower, they're 80. So plus 0.05 times 80 plus 0.6. Tests haven't gone as well, so your tests are 70. 70 plus your final exam, which is 0.2. And now, of course, you don't know what your final exam grade is going to be until, the course is over. So you can, use this and say, if you're wanting, you're wanting a C from this course, so put a 70 here and then do the calculation and solve for X. So add all these up. Let me see. So where are we? 0.15 plus, not plus, 0.15 times 85 plus 0.05 times 80 plus 0.6 times 70 equals, that's 58.75. So this would be 58.75 plus 0.2 times, and I don't even need those, 2x equals 70. Now, to move all the numbers, we're going to subtract by the 58.75. So we're subtracting by this number. And we get 2x equals, and you can't see my papers, 2x equals 70 minus 58.75, 11.25. So now, hold on, something's not right here. Yes, it is. This is 0.2. That's why. And we are going to divide by that 0.2 so that we can, move it over to this side. So these become a 1. X equals 11.25 divided by 0.2. And you get 56.25. So you would, with these numbers, you would need a 56.25 from your final exam to get a 70 in this class. So put in your assignment, quizzes, tests, and final exam, and then whatever grade you want, and then you can solve for that final exam. Okay, let's move on to the next page. Now we're going to the measures of position. We're going to define percentile first. So percentile is the pth percentile of a data set is a value such that p% of the numbers fall at or below this value. Okay, next we're going to look at a quartile. So we have this box split into 25%. 4 times 25% is 100%. So that means that this is the whole 100%, but then we have these in quartiles. So the first quartile is right here, where we have 25% of the data on this side. Second quartile is in, halfway between. So we have 50% here, 50% here. And third quartile, we have 25% here, and we have 75% here. Then we have what's called an interquartile range. And this, you'll see the abbreviation IQR. And that is the third quartile minus the first quartile. So these values here. Okay, let's look at example 4. Josie scored in the 73rd percentile on the verbal part of her College Board test. What does that mean? Again, 73rd percentile. The pth percentile of a data set is a value such that p% of the numbers fall at or below this value. So what this means, 73rd percentile, it means that 73% of the test takers scored at or below Josie's score. at or below Josie score. If we want to, turn it around, 100 minus 73 is 23 or 27, I mean. So 27% scored better. But 73rd percentile means 73% of the test takers scored at or below Josie's score. B. When a national sample of heights of kindergarten children was taken, Kevin was told that he was in the 35th percentile. Explain what that means. So this means that 35% of those kindergarten children that they had the data from are the same height or shorter than Kevin. So these are, I guess, the most common ones where you see, used. Testing scores are a lot of times given with the percentiles, like when you're taking a larger test, like a, um, you know, an overall assessment. Well, what are they called? I'm sorry. I totally lost the word. Like standardized testing, a lot of the times is scored with percentiles. So it doesn't mean that Josie got a score of 73% of the test, but no, it means 73% of the test takers scored at or below Josie's score. Same thing here. 35th percentile means that 35% of these kindergarten children are the same height or shorter than Kevin. So, for example, my son, who's always been tall, who's always been the tallest kid, he's 15 and he's 6'3" right now. So he has always been with his height in the 99th percentile, which means that 99% of his age group are same height or shorter. So so that's where you see the percentiles a lot of times, because we want to compare people here, even though we really shouldn't compare, because everybody's different and everybody should be different. But it's what we do. Okay, let's look at this example C. This is different. A union leader is told that when all worker salaries are considered, the first quartile is $27,750. Explain what that means. So, yes, this is $27,750. First quartile here. This is what we're talking about. So that means that 25% of workers' salaries are at or less than $27,750. Because first quartile is here, 25% is here, 75% of those worker salaries are going to be higher than $27,750. But 25, if it's the first quartile, it is 25% of those worker salaries are at or less than. Okay, next. We're going to look at the 19 top rated coffee makers. So here are their prices. And actually, so we're supposed to determine the first quartile, the second quartile, the third quartile, and the IQR, which is the interquartile range. Before we can do that, we actually have to write these out in numerical order. If we don't do that, we're not going to be able to figure out the quartiles. So I'm going to go ahead and do this here. do it on a separate piece of paper. I'm going to try to squeeze them in one line. I don't know if that's going to work or not. So what is our lowest price? I think it is $80. So I'm going to start with 80. I'm actually going to leave. We have three 80s, right? 80 and 80. Then our next price, I think, is 90. I'm going to leave the dollar sign out so that there's less here. Next one, I believe, is 100. 130. 150. And there's more 150. There's another 150 here. There's a third 150. Yes, that's it. And then our next one is 160. We have a 170 and a 170. Did I leave a 130 out? Yes, there should be a 130 here. So there should be a 130. This is why I'm crossing out, so I know which ones I leave out if I do. And then we have 180 three times, 1, 2, and 3. And of course, I can't fit all of these in here. Then we have a 200, 200, 230, and 300. It would be easier if they were all on the same line. But we'll figure this out. So what we're looking for here is basically this picture. So that we have 25% of these numbers, not 25% of an amount, 25% of these numbers marked, and we can mark the quartile 1, and quartile 2 for 50, and quartile 3 for 75. Now, how I recommend starting it is actually taking the second quartile. Notice that it's 50%. So 50% on each side of it. So that would be the easiest to start looking for. And we can actually, again, start from the ends and cover the numbers or count the numbers from both ends so that we are on the same 130, 150. And here's, so 150 is in the middle. And if we count the number, we have 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9 are on this side. 1, 2, 3, 4, 5, 6, 7, 8, and 9 are on this side. So we have 9 numbers on both sides of this. So this is your quartile 2, which is here. So $150. Now, next we're going to look for that quartile 1. Well, we've got our quartile 2, so we're basically looking at these numbers here. So again, 1, 2, 3, 4, and 5. We have 4 numbers here, and we have 4 numbers here. So this is our quartile 1. That would be $100. Same thing for the third quartile. 1, 2, 3, and 4. So this here is our quartile 3, third quartile, and that is $180. Again, we have 4 here and 4 here. Now, for the IQR, we're taking the third quartile and subtracting the first quartile for men. So the third, which is $180, minus the first, which is $100, and that is $80. And that is your interquartile range. Okay, so where do we use this? We use it in what's called box and whisker plots. So here we have our interquartile range. So we have our first quartile, third quartile, our median, which is the second quartile. So quartile 1 is the 25th percentile, quartile 3 is the 75th percentile, and then we have our minimum, maximum, and then we have our outliers. So our minimum is calculated like this. We take the first quartile, subtract 1.5 times the IQR, the interquartile range. Maximum is third quartile plus 1.5 times the interquartile range. So what we're going to do here is we're going to take these scores for 10 students and make a box plot for these first exam scores and figure out if there are any outliers, if there are, identify them. So first, what we need to do is we need to reorder these scores from the smallest or the lowest to the highest. So I believe our lowest is 55. Then we have a 73, a 75, 80, another 80. What else do we have? 85. We have a 90, a 92, a 93, and 98. So now again, we want to find the median, where the median is. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 students, so we have 10 of these. So what's going to happen is we need the median is going to be in the middle. 1, 2, 3, 3, 4, 5. So the median is going to be in between these numbers. Here's our median, which is the quartile 2. So it's in, so we need to calculate what it is. 80 plus 85 divided by 2. And we get 82.5. We're going to leave that decimal right now. Next, we need to figure out our quartile 1 and quartile 3. So, well, that's easier because now there's, 5 numbers here. So the middle one here is, this one is quartile 1, and the same thing, this one is quartile 3. So we have the box here. Before we can do anything else, we need to figure out our interquartile range, our IQR, and then our minimum and maximum. So our IQR is going to be 92 minus 75, which is 17. IQR is 17. Our minimum here, so the minimum is going to be Q1, which is 75, minus 1.5 times the IQR. 1.5 times the IQR. IQR is here, 17. And when we do this calculation, we get 49.5. Our maximum is Q3, which is 92, plus 1.5 times IQR, which is 17. And this becomes 117.5. Now we can draw this here. So let's see. We're going to draw our box here. So we have our box here. We have the median. And actually, you know what? we need a number line here. So we need these numbers on a number line before we can actually do this. Do the box. Sorry about that. Let's start over. I don't know why I forgot about the number line. Yes. So here's our number line, and we're going to start the number line. I'm going to start it with, well, our minimum is 49.5. So I'm going to start the number line with 45. And our maximum is 117.5. So we want 120 over here. So 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, and 115. Wow, it actually. So this here is our number line. And now, you know what? I'm going to make this a little bit bigger so hopefully you can actually see. Here we go. So our median is 82.5. So here's 80 and 85, so it's in between. So here's our median. This is the median. Then our first quartile is 75, which is here. Hold on, 75 is here. So this is Q1. Third quartile is 92, which is somewhere here. And my lines are not straight. And now I can draw the box. So we have our Q1, median, and Q3. Next, we're going to draw these whiskers. So we have our maximum and our minimum. So our whiskers go to 49.5, which is over here somewhere, about. So this is our minimum. Our maximum is 117.5, which would be somewhere here. So those are our whiskers. And now it's asking, are there any outliers? If there are, identify them. Well, we don't have a number that is smaller than 49.5, and we don't have a number or a grade that is higher than 117.5. So no, there are no outliers in this one. So no outliers. Okay. Next, we're going to do a box plot for Bob's monthly living expenses for 1 year. So the exact same thing that we just did. So we're going to go ahead and rewrite these in an order from the smallest to the largest. So what do we have? Where's our, I think 1,050. Those are our smallest amounts. 1050. Next one is probably 1100. Then we have, hold on, 1200 was what I saw here. We have 1310. We have 1430. We have 1450. We have 1550. 1570. So that's 70. 1600, 1800, and 2000. And again, that 2000 should fit, but it doesn't. Okay, so here are our numbers. Now, the same steps. we're going to find the median first. So how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, because there's 12 months, it's 1 year. So we're going to do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So these two. So in between here is the median, which we have 1,430 and 1,450. So 1,440 would be in between. Again, you could do the calculation by adding these and dividing by a 2. Next, we're going to look at the first quartile. Well, we have 5 numbers here. Or actually, we don't have 5 numbers. We have 6 numbers here. So 1, 2, 3. So the same thing here. We're going to look at these two. So quartile 1 is in between. And since it's 1,100 and 1,200, the number in between is 1,150. Well, here, 1, 2, 3, 1, 2, 3. So our third quartile is 1,570. So 15, that's not as easy. Plus 1,600 equals divided by 2, which is 1,585. Okay, so now we have those numbers. We can actually go ahead and draw the box, or start drawing the box plot. We can do the number line here. I'm going to start with 1,000, and then we want to go up to 2,000. And we're going to go in increments of 100. 1,400, 15, 16, 17, 18, and 1,900. Okay, so our median is 1,440. So that is somewhere right here. This is our median. First quartile is 1,150, so that would be right here. That's our Q1. Oops. Yeah, I should use a ruler here. Third quartile is 1,585, so that's about here. There you go. There's our box. Now the whiskers. So our IQR here is 1,585. Again, it's the third quartile minus the first quartile. That would be what? 1,585 minus 1,150. 435. And then our minimum, again. So the minimum is that Q1 minus 1.5 times IQR. Maximum is Q3 plus 1.5 times IQR. So our minimum is 1,050 minus 1.5 times 435, which is 1,150 minus 1.5 times 435, and that becomes 497.5. Oops, 0.5. That 0 doesn't, well, it really doesn't make a difference. It does when we're talking about like physics or chemistry, because that 0 has a meaning, but here it really, there's not that much of a meaning, or if we talk about money as well. Okay, maximum. Third quartile, 1,585 plus 1.5 times 435. 1585 plus 1.5 times 435 is 2,235 and 75. So for this one, our maximum is going to go all the way somewhere here. Our minimum, 497.5. So we don't have that. That's going to go out of our range as well. Way over here. So this is 497.5, whatever, wherever it is. And this one here is the 2,200. 2,200. Why did I not? 2,237.5. So, are there any outliers? No, there are not. None, because nothing is under 500 and nothing is over 2,200. So there are no outliers for this one either. Example 7, on each number line. Example 2, draw a box plot. I need to find my example 2. Okay. So this is my example 2. Now, I actually don't have room here to draw those box plots.